Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, our lesson today, we are actually starting on a new topic now, and we are moving away from rocks. Today, we are going to look at denudation, and under denudation, we are going to look at the different processes which comes under that particular topic. We'll go through that later on in the lesson, but before we do that, I'd like us to look at the correction to the activities you were assigned to complete for your homework. Okay, the activities, there were 4 activities you were expected to do for homework. We double check now and make corrections. You were given a list of minerals, and from those lists, you were supposed to do 4 things. Number 1, you're supposed to put them correctly under the 2 groups or headings, those minerals which are ores and those minerals which are precious stones. That's the first activity you were supposed to have done. Number 2, for each ore, you were supposed to state the metal which is obtained from it. Number 3, for each of the precious stone, you were supposed to give the color. And finally, you were expected to explain the difference between ore and precious stone. We'll start off first with the first one, and let us see where you have put those different minerals, or under which heading those different minerals were supposed to be placed under. The minerals are diamond, chalcopyrite, galena, opal, hematite, ruby, emerald, and bauxite. Question 1, answer. Kathy, your answer for number 1. You're going to give the answer by simply telling us which minerals come under which heading. And the rest of us will check and make corrections. We'll start off with the ores.
Under the ores, I have chalcopyrite, galena, hematite, and bauxite. Under precious stones, I have diamond, opal, ruby, and emerald.
We agree with her? Definitely. So there is a balance here. We can see 4 examples of ores and 4 examples of precious stones. So we double check and make your correction. Under ore, you have chalcopyrite, you have galena, you have bauxite, and hematite. Under precious stone, you should have diamond, ruby, opal, and emerald. And if you got those under the 2 headings, then give yourself a tick. Well done. We'll move on to number 2. Question 2. This time, we are going to find out from all of those that we've put under ore, from which metal, sorry, not from which metal, but which metal is actually obtained. Okay, we'll start off with chalcopyrite. The answer for chalcopyrite.
The metal obtained from chalcopyrite is copper.
Copper? We happy with copper? Okay, good. The next one, galena. Catherine.
The metal obtained from galena is lead.
Lead? Correct, good. The next one, which is bauxite.
The metal obtained from bauxite is aluminum.
Okay, aluminum, we're happy with aluminum. Okay, and that's also correct, good. And finally, from hematite?
The metal obtained from hematite is iron.
Iron is correct. Okay, we'll check again on the answers given. We have hematite, iron, chalcopyrite, copper, galena, lead, and bauxite, aluminum. You check, make your corrections. We all happy with the answers then given? Okay, good. We move on. Dorothy, this time, the next part, which is exercise 3. For all of those minerals that we have put under precious stone, now we are going to give the color. So we start off with diamond?
Diamond is crystalline blue or yeah, or it's clear.
Okay, clear or crystalline blue? Clear would be a little bit better, or we can say transparent. Okay, colorless, okay, yes. Perhaps a better word then would be clear or transparent. So if we are saying diamond is clear, transparent, that's correct. You can give yourself a tick. Okay, the next precious stone, ruby. Shelley?
Ruby is red.
Red? We all happy with the color red? Yes. Okay, some people might want to say black red or dark red. You can, or deep red, yes. We can also have that. As long as you have the red color given for ruby, you can give yourself a tick. Deep red, dark red, some people may say black red, still okay. Okay, the next precious stone, gibbous, emerald.
Green.
Emerald green? Yes, definitely, that's correct. And finally, opal, Gao?
Opal is white.
White, opal white. Perhaps a little bit of white in that mineral, precious stone opal. Is it a lot of white in it? A lot more of the rainbow color, and blue would be a little bit more dominant within that mineral opal. So perhaps blue might be what we're looking at, but opal also can be with rainbow color. Most of the color in an opal is mainly green-blue, but blue is a little bit more outstanding. Okay, so here maybe we can say the dominant color then blue. We'll leave it at blue as our answer. We'll double check now from the answers on our screen or monitor. What we have put together here are some examples of pictures showing those different metal or ores that we have looked at, plus the precious stone that we have also looked at for our homework exercise 2 and 3. So for hematite, you see iron as the answer that we've given, a photograph or a sample of that. We're looking at the metal or the ores, that is chalcopyrite and copper, a sample or a photograph showing that. Galena, you said lead, again a photograph showing that. And bauxite, of which we said aluminium, and a sample or a photograph showing that particular answer. Okay, for our answer to the precious stone, diamond, we said it was transparent color or clear. Ruby, black, red, we said red mainly. Emerald, green, and opal, rainbow color, mainly blue. Okay, let's look at some of the pictures or photographs again to show those different colors and the precious stone that we have just looked at for that activity. Samples of diamond. You can see the transparent color. Okay, we have ruby, that red color. Opal, yeah, rainbow color, but a more bluish color that you can actually pick out from there. And finally, emerald, green color, which you can actually pick out from there. The last question for our homework. You're supposed to explain the difference between ore and precious stone. Your answer. And the rest of us to make corrections.
The difference between an ore and a precious stone is that an ore is a natural substance yielding a non-metallic material, while a precious stone is a stone that is rare, very hard, and is very precious.
Okay, rare, very hard, precious is given the characteristic. And don't forget, for the ores, they are supposed to be minerals which contain metals, and they are the ones which are worth mining. Okay, so we double check now with the answers that the answer that is given, and we can also make correction with the answer from the monitor. Okay, from the monitor it says that ores are minerals which contain metals and are worth mining. Precious stones, they refer to very hard minerals, which is often cut, polished, and used for jewelry, especially if they have an attractive color and are free from flaws, which means it cannot fault or break or crack easily. And also note that because they are precious, they are rare. If there's so many of them around, then it might not be precious. And because they are rare, only a few of them, that's why they are identified as precious stones. Okay, we also make correction to exercise 4. We all happy and satisfied with the answers that we've given for those activities? Yes? Okay, if we have done our corrections, then we are now ready to move on to looking at our topic. And the topic on denudation is going to take us a couple of lessons to complete, because I am going to actually break the topic into looking at the different processes on its own, and as well as that we will do we will look at some examples of those different processes. And you will also, during the course of our study on the topic on denudation, be required to do presentations similar to what you have done on the presentation of the rock cycle. Okay, having done your corrections now on the exercises, we are now ready to move on to looking at our topic for today, and the topic is on denudation. If you can make reference to your booklet's Introduction to Physical Geography. That's the first booklet that we were using for our work on the content geography. And if you looked at that booklet, you would have found that the topics we have covered so far are actually to do with building up of the land. The topics of tectonic movements, volcanicity, diastrophism, and even to do with rocks and the rock cycle, they're all to do with building up of the land. This particular topic now you will find on the last pages of the booklet Introduction to Physical Geography, and it comes under the heading of Weathering and Erosion. And in our work in geography, we must always look at the balance. Whatever is being built up will have to also be worn down or broken down. There is a term in geography that we would usually use to describing that balance, and the term is referred to as isostasy. We'll look at that in detail in grade 12. So we are now looking at the balance. Whatever has been built up will have to be broken down. So when we come to this particular section now, from the introduction, it tells us that in addition to the landscape being affected by tectonic or earth-moving processes, the earth is also shaped by other processes. And those other processes can be referred to as the denudational process or processes. So what does denudation involve? Denudational processes involve those processes which aid in weighing away of the land or lowering of the land surface. In the building up, the land actually gets to be built up. Tectonic forces, volcanicity, diastrophism. Then we come to denudation, and denudation has to do with the lowering of the land surface. There are 3 important processes which comes together with the topic on denudation. And those 3 processes are, number 1, weathering, because weathering breaks down or disintegrates rocks especially. And the breaking down of rocks we are going to look at in detail in our lesson today can be physical or mechanical breaking down, it can be chemical breakdown, or it can be biological or biotic breaking down. So one of the important processes in denudation that helps wear down the land is the process of weathering. The other important process which comes in with denudation is that of mass movement or mass wasting. In mass movement or mass wasting, it is simply to do with the movement downslope of weathered material. But this is to do mainly with the force of gravity. Gravity pulls everything down, and any materials, especially which have been broken down, which are on slopes, when they move down the slopes due to the force of gravity, then we say they come under mass wasting or mass movement. We're going to cover mass movement in great detail in grade 12. But I am just telling you now that mass wasting is also an important process with denudation. And the third process that comes together with denudation, which helps in lowering the land surface, is that of erosion. And erosion is simply the process by which rocks are worn down by the moving agents. And the agents of erosion are water, wind, and ice. So we are going to look at number 1, which is weathering, and number 3 in detail under the topic on denudation, whereas for mass wasting, we will cover that in grade 12. So if we had to put that information simply, perhaps on a summary chart, here you can see denudation definition is mainly to do with processes which wear down and lowers the land surface. Those processes are weathering process, the mass wasting or mass movement, and erosion. Here I have a diagram to show that. Note, number 1, rock weathering. Number 2, mass movement. Number 3, erosion. And in erosion, we know that transportation comes in together with erosion. Finally, we have also from this diagram here, deposition. We'll double check now on what we have covered on the introduction quickly. Can someone explain to us what you understand by the word denudation, or what is denudation? Noel, what is denudation?
Denudation is simply the lowering or wearing down of the earth's surface.
Okay, very good. It's simply the lowering or the weighing down of the land surface. What are the 3 processes which are involved in weathering? Terence. Sorry, not in weathering. I'll repeat that question. What are the 3 processes which are involved in the process of denudation?
Weathering, erosion, and mass wasting.
Okay, mass wasting or mass movement. Rodney, can you explain what weathering involves? Oh, sorry. Renagi. Renagi, what does weathering involve in or under the process of denudation? Or what is weathering?
Weathering is a process which breaks down
The process which?
break down rocks by mechanical, chemical, and biotic process.
Okay, so in other words, it's simply the breaking down of rocks. Okay, beside weathering, there is also mass wasting, of which I said we will cover in detail in grade 12. But generally, what is mass wasting? Gideon, what is mass wasting? Mass wasting or mass movement?
Mass movement is the movement of weathered material attracted to gravitational forces.
Okay, and don't forget, you must also include movement downslope, owing especially to gravitational force. Good. And finally, erosion. Francis. erosion. What is erosion, or what do you understand by the term erosion?
Erosion is the process by which rocks are worn by a moving agent, for example, wind, water, and ice.
Okay, rocks are worn down by the moving agents of water, wind, and ice. In simple terms, erosion is simply weathering and transportation. When rocks are weathered, that means they are broken down. And when they are moved, they have been transported. So erosion covers both breaking down and the movement. So therefore, we can say weathering is simply, erosion is simply weathering and transportation. Okay, so this is introduction to the work on denudation. Caleb, would you like to explain to the class why I did not include deposition as a process of with denudation? Caleb doesn't know. Why do you think I have not given deposition as one of the process which should come with denudation? Ovio? Okay, Ovio is going to try because Caleb said he does not know why this is not a process of denudation. The question again, why is it that deposition is not included as a process in denudation? From our monitor, there are 3 processes which comes under denudation: weathering, mass wasting, and erosion. But it does not include deposition. So tell us why you think it does not include deposition. No? Okay, Noel's got his hand up, so if you can pass the mic down.
Deposition is not included because it probably is a process where the land is built up.
Very good. Well done. In deposition, when materials are deposited, it does not lower the land. Rather, it raises the land. Therefore, deposition is not included with the process of denudation. You come back to the definition. The definition tells us that denudation are the processes which help in wearing down and lowering the land surface. In deposition, it does not lower. The deposition raises the land. Therefore, it cannot be part of denudation. Well done. But the reason for why it's included here is because when rocks are broken down, when they are transported or moved, they will finally get to be deposited. But we should not see deposition as part of denudation. It is a process on its own. Okay, we move on. We are going to actually look at rock weathering in our lesson today. And for the work on rock weathering, you would have noted also that weathering of rocks can be done physically or mechanically. Weathering of rocks can be chemically done. And weathering of rocks can be biotic or biologically done. So when we look at weathering, we say that it is a process which breaks down or disintegrates rocks. And it can be done in 3 ways. Those 3 ways are mechanical, chemical, or biological. We look at the first example of weathering, and that is physical or mechanical. When we look at rocks being broken down under physical or mechanical weathering, what does it involve? Note there, it says that this is the breakdown or the disintegration which is caused by mechanical force or forces involving expansion and contraction of the rock. The rapid change of temperature from day to night, particularly in mountain areas and also in desert regions, causes some rocks to expand and some to contract. Some rocks split away when they go through the process of contracting and expanding. For example, we look at a rock like granite. Granite, we know it is an igneous, intrusive rock. When granite is actually compressed underground, and the compressing of granite underground will be as a result of the weight of the other rocks on top of it. So when granite is formed, it's underground. When it is compressed, joints or joint planes will start to develop. And when the pressure of the rocks which are on top of it are removed, then what happens is the rocks or the rock of granite will start to split. And the splitting is an example of a mechanical or physical weathering. Sheets split away from the main mass of that rock of granite, and when that happens, we can say disintegration or physical or mechanical weathering has taken place. Let us look at some examples under the heading of physical or mechanical weathering. But before we do that, we must be able to identify what is physical or mechanical weathering. And from being able to identify physical or mechanical weathering, we should be able to tell the difference between whether a rock has been chemically broken down, whether it has been biologically broken down, or whether it has been physically or mechanically broken down. We are looking at the first example of weathering, which is physical or mechanical. Okay, looking at physical or mechanical weathering. Physical or mechanical weathering is the disintegration of rocks which is caused mainly by stress and or strain. You see, if a rock is out there and that rock is put under great stress or strain and the rock breaks, then we can identify the type of weathering as physical or mechanical. Stress or strain. You put a rock, you get a sledgehammer, break it. What are you adding to that rock? Pressure, stress, strain. Smashing the rock, example, physical, mechanical. But when we look at physical or mechanical weathering, it is to do with the natural processes which contribute to their breaking up. The example I gave is a human impact, which we can also classify the way in which the rock has been broken as physical or mechanical. Okay, examples which we are going to look at, which comes under physical or mechanical weathering. Number one, pressure release jointing. And in pressure release jointing, the example I gave earlier on granite is a classic example. Rocks which are under the surface are actually under the pressure of the rocks which are lying on top of them. When those rocks at the surface are removed, then the pressure is released. Cracks or joints start to develop, resulting in splitting. When we have an example of such, it is under pressure release jointing. Another example of physical or mechanical weathering is that of thermal expansion. When we look at thermal expansion, we are going to look at heating and cooling of particles in rocks especially. And when particles of rocks are actually heated or cooled, they tend to expand and they tend to contract. And the expansion and the contraction will contribute also to the rock breaking up. And a classic example of that will be exfoliation, especially in desert regions. Then we have freezing and thawing, which is also an example of physical or mechanical weathering. Freezing and thawing is actually common mainly in temperate regions of the world. Also, if it is within the tropical region, it will be in high mountain country where temperatures perhaps go below 0 degree. And in freezing and thawing, it is simply cracks in rocks collecting water. When the temperatures go below freezing, then this water are actually changed to ice. And when water changes to ice, the ice tend to occupy more space. Therefore, the more space it occupies, it means that it will have to open out the cracks where the water in liquid form had collected earlier on. The cracking then comes under freezing and thawing. Then there is also plant and animal action. One might be wondering, perhaps plant and animal action should come together with biotic or biological weathering. But the actions of plants and animals can also contribute to stress and strain exerted on rocks, resulting in them breaking up. Therefore, they can also be classified as physical or mechanical weathering. We also have number 5 example, which is salt crystallization, and number 6, hydration, of which 5 and 6 we are going to look at in detail in grade 12. For now, we will concentrate only in 1, 2, 3, and 4, the 4 examples under physical or mechanical weathering. Any questions so far? Caleb, questions? No questions? Okay, we move on. Looking at the first example now of pressure release jointing. I mentioned earlier on, deep in the crust of the earth, rocks are kept under pressure by the weight of the rocks which are above them. As the surface rocks are actually removed through the process of weathering and erosion, pressure on those rocks which are under the surface are gradually removed or released, and the rocks which are under the surface then expand and they crack. We look at perhaps a photograph to actually show that process of pressure release jointing. We have all the rocks here under the surface. The rocks under the surface are actually under pressure due to the weight of the rocks above them. The process of weathering and erosion, perhaps erosion by river to remove some of those rocks at the top, will mean the pressure which is exerted on those rocks at the bottom are released. And when the pressure is released, the rocks then expand, and upon expansion, they crack or split. When that happens, that's a sample or an example of pressure release jointing. Another good example of pressure release jointing. If you get a new book, a new textbook perhaps, you look at where the pages are on your textbook. Okay? You place that on the table. Keep your eye on the way in which the pages are actually moved when pressure is actually released. Can you see from that end if I put the book on the table? Okay, perhaps here. My hand might act as the pressure on the surface on those rocks which are beneath. Let's concentrate on this side of this book here. Okay, pressure exerted, all the pages are closed, very close together. What happens when I release when I remove my hand? You can see the splitting occurring, and that's exactly also what happens to rocks which are under the surface when rocks on the surface are removed. And that example is an example of physical or mechanical weathering, and it comes under pressure release jointing. I think I have time to also look at the other 3, and then I'll leave it at that. I will ask you then to go and do your own note-taking under those examples of physical or mechanical weathering, and we'll look at more maybe examples or more information on that in our lesson tomorrow. Let's look at the sample or example which has been put together on the rock of granite. We know that granite is an intrusive igneous rock. If we are looking at the gray color here, or not gray but perhaps brown color, that shows perhaps rocks of granite. The arrow, they indicate the pressure which are exerted on the rock of granite underground, that is. Erosion of the rocks above will mean the pressure is released, and you can see now joints or cracks develop. Splitting has taken place, and here we have an example of physical or mechanical weathering. A photograph showing sheeting in the Grampians, which is an example of mechanical or physical weathering. You can see the cracks along the sides here, which have occurred as a result of rocks at the top being removed. Pressure release jointing. The second example, we look at it also, heating and cooling. For heating and cooling, you note that rocks do not conduct heat very well. Only their surface expand in the heat of the day and contract at night. Perhaps the type of environment of which this type of weathering could be best developed and explained in would be a desert area. Because in a desert area, during the day, the temperatures are very high, and during the night, the temperatures go very low. So if we are looking at the surface of the rocks expanding in the heat of the day and then contracting at night, then the desert might be the best place to look at this type of example. So what happens if continuously during the day the surface of the rock expands, during the night it contracts, and then the next day the same thing? Finally, the surface will peel off or break off. And when that happens, a term that we use to describing this type of weathering is exfoliation. The Americans would call exfoliation onion skin peeling. You think of an onion. When the onion is growing, the round onions, the brown outer cover of the onion breaks because of the expanding of the onion when it is growing. So the Americans would call exfoliation onion skin peeling. But the term is basically referred to as rocks contract and expand during the heat of the day and the coolness of the night, resulting in their surface area peeling off. Okay? You look at perhaps a photograph of exfoliation taking place there. You can see the peeling off of the outer surface. And again, the environment, arid desert type region we're looking at. Can you see the cracking, the outer layer of this rock removed or peeling off? Here is another example of exfoliation. Okay, and if you had to sketch a diagram to actually show that process of heating and cooling, you could show originally with that area which is the dotted section. Continuous expanding and contraction will mean the area which is with the line there being removed, and now you can see the original surface after that process. Given time, that area might be removed and the next layer until finally the rock disintegrates into tiny pieces. But again, this will take a long time, not just within a couple of days or weeks for it to occur. And also, because we have also run out of time, I might as well stop with the two examples. But let me give you your homework. What I'd like you to do for your homework is I'd like you to ensure that you have your notes for the first example on physical or mechanical weathering, and that is pressure release jointing. Explain what pressure release jointing is. And number two, explain the process of heating and cooling, and also the term exfoliation. If you'd like to have diagrams to show those two examples, you could also get your diagrams constructed and well labeled to show those two examples. We look at the other two examples on plant and animal action and plant and animal action plus freezing and thawing in our next lesson. Okay, class, that also brings us to the end of our lesson. If you can now stand up. Okay, to the pilot teachers, our keyword for lesson 62 is frost shattering. Good afternoon and thank you, class.